Hello students, I am Dr.R. Professor, Department of Mechanical Engineering, RVS College of Engineering, Dindigul. This is the continuation of the previous videos. This is mainly for introducing you the MCQ models, multiple choice question models for the subject robotics, ME 8099 as well as OAE 751. So this video we are going to see the multiple choice questions for unit 2 about drive systems and end effector. As I mentioned in the previous video, we are having part A questions as well as part B questions in an university examination. So we will see the part A questions first, then we will go for part B questions. The question number 1, which of the drive has highest power to weight ratio? A. Pneumatic, B. Hydraulic, C. Electric. It is not pneumatic actually, it is electric. Which of the drive has highest power to weight ratio? A. Pneumatic, B. Hydraulic, C. Electric. So the power to weight ratio is higher for hydraulic systems, hydraulic drives. So the answer is B. Question number 2. Which one of the following is rotary drive? A. Hydraulic cylinder, B. Pneumatic cylinder, C. Hydraulic motor. So the answer is C. Hydraulic motor. So the cylinders are linear drives, either it is for hydraulic or for pneumatic. The cylinders are linear drives. So by providing the pressure, they are going to reciprocate. The cylinders are going to reciprocate. So they are called as linear drives. The rotary drives are motors. So in this case, C is the correct answer. C, hydraulic motor. Third, based on accuracy, the drive systems can be arranged in the following manner from poor to best. A. Pneumatic, hydraulic, electrical. B. Hydraulic, electrical, pneumatic. C. Electrical, pneumatic and hydraulic. The answer is A. So the accuracy of the system, it is asked for poor to the best. So poor to the best, when you are considering poor to best, the pneumatic drives are having poor accuracy, hydraulic drives are having better accuracy than the pneumatics, electrical drives are having better accuracy than the hydraulics. So in this case, we have to consider the electrical drive system. So as the best actually. So pneumatic, hydraulic, electrical, that is the right answer. Answer A. Fourth question, based on force or torque developed, the drive systems can be arranged in the following manner from high to low. So now it is in descending order, high to low. A. Pneumatic, hydraulic, electrical. B. Hydraulic, electrical, pneumatic. C. Electrical, pneumatic, hydraulic. So always remember the highest torque or the force that can be developed that we can get from hydraulic system. So from high to low, here it is given. So the question answer, the option B is the right answer. So answer B, hydraulic, then electrical, then pneumatic. So the here in this case it is asked from high to low. So that's why we are considering B is the correct answer. Hydraulic, electrical and pneumatic. Fifth question. In permanent magnet stepper motor, which one of the following is true? A. Torque developed is more. B. Step angle is small. C. There is no back EMF. So in this case, the answer is, the option is A. So in permanent magnet stepper motor, the step angle is going to be larger and there is back EMF also. These two are the drawbacks of permanent magnet stepper motor. So the first one is the right one. Torque developed is more. In permanent magnet stepper motor, torque developed is more. The second, sixth question. In variable reluctance stepper motor, the rotor is A. permanent magnet, B. toothed wheel, C. magnetic toothed wheel. So the second type of stepper motor is called as variable reluctance. First one we have seen PM stepper motor, permanent magnet stepper motor. In variable reluctance stepper motor, the rotor is a toothed wheel. So the option B is the right answer. B. toothed wheel. Question number 7. When high speed and high torque are needed, which one of the stepper is more suitable? A. permanent magnet motor, B. variable reluctance motor, C. hybrid motor. So the answer is C. hybrid motor. So when you require high speed and high torque, then the choice is C, that is hybrid motor. The purpose of off or microstripping is to reduce the step angle. A. reduce the step angle, B. increasing the resolution, C. get smoother operation, D. all of the above. So the purpose of off or microstripping is all the three, that is reduce the step angle, increasing the resolution, get smoother operation. So the answer is D. all of the above is the right option. Our answer is D. Question number 9. In a brush type permanent magnet DC servo motor, stator is permanent magnet and the rotor is winding. B. stator is winding and the rotor is permanent magnet. C. both stator and rotor are permanent magnet. So here is a brush type magnetic DC servo motor. In this case, the stator is going to be permanent magnet and the rotor is winding. So the answer A is correct. So stator is permanent magnet and the rotor is winding. So question number 10. In brushless type permanent magnet AC servo motor, the commutation is achieved by. So in the case of brush type of permanent magnet DC servo motor and brushless type permanent magnet DC servo motor, there are two types of DC servo motors are there. So in a brushless type permanent magnet DC servo motor, the commutation is achieved by A. commutator, B. Hall effect sensor, C. no commutation is needed. So the answer is B. So in the case of brush type of permanent DC servo motor, the commutation is achieved by a commutator. In a brushless type permanent magnet DC servo motor, the commutation is achieved by Hall effect sensor. 11. Which one of the following is false? A. Stepper motor has no feedback. Resolution of servo motor is higher than stepper motor. Steppers are used for high torque and high speed applications. So stepper motor has no feedback. That is a true statement. Obviously that is a true statement. And steppers are used for high resolution of servo motor is higher than stepper motor. That is also a true statement. So the only false statement in this question is steppers are used for high torque and high speed application. So the option is C. So answer is C in this case. 12. In grippers, the holding elements are called A. jaws, B. fingers, C. toes. So in grippers, the holding elements are called fingers. In internal grippers, the object is gripped with A. open fingers, B. closed fingers, C. partially open fingers. So internal internal grippers, the object is gripped in the hole present in the object or the hole present in the object. So obviously when the fingers are in open condition only, the object can be gripped. So internal grippers, the object is gripped with open fingers. That is not answer B is not the right answer. Actually answer A is the right answer. In internal grippers, the object is gripped with open fingers. It is not closed fingers. It is open fingers. Internal grippers is gripped. The object is gripped with open fingers. So in external grippers, the object is gripped with closed fingers. That is the right answer. So in this case, the answer B is not correct. Actually, the answer A is correct. In internal grippers, the object is gripped with A, open fingers. Encompassing grippers grasp the object by A, physical constraining, B, friction, C, touching. Encompassing grippers grasp the object by A, physical constraining, B, friction, C, touching. The answer is A. So encompassing means we have to grasp the object by means of the fingers are having the similar shape like the object, and we are going to constrain the object physically. So that's why it is called as physical constraining. Encompassing grippers grasp the objects by physical constraining. Question number 15. In pivoting gripper mechanisms, the motion obtained is A, swinging, B, translational, C, rotational. Answer is A. So any pivoting gripper mechanisms, the motion is going to be a swinging motion. It's like our jaws in the mouth. So it is going to be swinging action. So the swinging, A, swinging is the right answer. Question 16. The translational motion in the gripper is achieved by A, rack and pinion mechanism, B, slider crank mechanism, C, swing block mechanism. So answer is A, because the other two, slider crank mechanism and swinging block mechanism, they are going to provide a swinging motion. So the rack and pinion mechanism, which is going to give a translational motion. So the answer is A. So rack and pinion mechanism gives the translational motion. So the answer is A. Question number 17. The spherical objects can be tightly grasped with A, two-fingered gripper, B, three-fingered grippers, C, vacuum grippers. So the answer is B, three-fingered grippers. When we are handling spherical objects cannot be handled by two-fingered grippers. So in that case, we require another one more finger. So three-fingered grippers are more suitable for handling the spherical objects. So the answer is B. Question 18. Which of the following cannot be handled by a vacuum gripper? A, flat glass plate, B, flat steel plate, C, perforated steel plate. So which one of the following cannot be handled by a vacuum gripper? So flat glass plate can be handled by a vacuum gripper. Flat steel plate can also be handled by a vacuum gripper. So cannot be handled, that means the C is the right answer, perforated steel sheet. Because in a perforated steel sheets, the vacuum cannot be created. So that's why perforated steel sheets cannot be handled by a vacuum gripper. Answer C is the right answer. Question number 19. Which one of the following can be handled by a magnetic gripper? A, glass plate, B, paper cotton, C, steel block. So magnetic gripper can handle only ferromagnetic materials. So glass plate and paper cotton are not ferromagnetic materials. So the answer is C, steel block. So answer C is the right one. Question number 20. The disadvantage of magnetic gripper is A, unable to handle perforated sheets, B, residue magnetism. C. Slow pickup. So the disadvantage of magnetic gripper is unable to handle perforated sheets. B. Residual mechanism. C. Slow pickup. So in this case, it can handle perforated sheets as well as the magnetic gripper is having a very fast pickup. So the disadvantage of magnetic gripper is residual magnetism. So answer choice B is the right answer. So answer is B. 21. In adhesive grippers, the object is handled by A. Magnetism, B. Tackiness, C. Vacuum. In adhesive grippers, the object is handled by A. Magnetism, B. Tackiness, C. Vacuum. So the answer is B. Tackiness. So by the tackiness, it sticks to the object and then it handles the object by using the tackiness. Magnetism for magnetic grippers and vacuum for vacuum grippers. And question 22. Adhesive gripper can be used to handle A. Fabrics, B. Steel sheets, C. Granular substances. So the answer is A. Fabrics, because adhesive grippers do not have more force to handle the objects like steel sheets, and the granular substances cannot be handled by adhesive gripper. So the answer or the choice is A. Fabrics. The granular substances, question number 23, the granular substances can be handled by A. Mechanical gripper, B. Hook, C. Scoop. So the answer is C. Scoop. So the scoop is used for handling the granular substances. So hook cannot be, hook or mechanical grippers cannot be used for handling the granular substances. So the answer is C. 24. The ladle can be used to handle A. Molten metal, B. Containers, C. Steel blocks. So the ladle is used for liquid metal and can be used to handle liquid metal. So A is molten metal. So that is the right answer. Answer is A. Question 25. While designing the gripper, which one of the following factors should be considered? A. Shape of the object, B. Accuracy, C. Speed and acceleration, D. All of the above. So D is the right answer. We have to consider shape of the object, accuracy, as well as the speed and acceleration, all the factors. So D is the right answer, all of the above. So next we are going to see the part B questions. Question number 26. In a stepper motor, the number of pulses per second is 200 and the step angle is 6 degree. What is the speed of the drive in RPM? A. 100 RPM, B. 200 RPM, C. 500 RPM. So in this, the basic concept is, for each pulse, the stepper motor is going to move one step angle. So in the case, the total step angle moved is equal to the number of pulses per second into the step angle. So the speed of drive in RPM is equal to pulses per second into step angle divided by 360. That is the revolution. So for each revolution, it has to move 360 degrees. So what is the total degrees it moved? Pulses per second into step angle divided by 360. This will give you revolutions per second. And I multiply it with 60 to make it as revolutions per minute. Okay. So the reason for multiplying this 60 is RPS is converted into RPM. So 200, that is pulses per second, multiplied by 6, that is the step angle, 360, that is angle per revolution, 360 degree, into conversion factor, that is RPS to RPM, that is 60, that is equal to 200 RPM. So answer B is the choice B is the right answer. B is equal to 200 RPM. B 200 RPM is the right answer. 27. The step angle of a stepper motor is 1.8 degree. If the motor shaft has to rotate 15 complete revolutions, what is the required number of pulses? So the step angle of the stepper motor is 1.8 degree. The motor shaft has to rotate 15 complete revolutions. What is the required number of pulses? A 2000, B 3000, C 4000 pulses. So number of pulses is equal to, so what is the total angle required? That is number of revolutions into 360. Each revolution it has to move 360 degrees. So number of revolutions into 360, that will give you the total angle the stepper motor has to move, divided by, for each pulse it has to move one step angle. So we are dividing it by the step angle. So 15 into 360, this is the total angle to be moved, divided by each step angle, that is 1.8 degree, is equal to 3000 pulses. So we need to provide 3000 pulses to get a revolution of 15 revolutions, to get 15 revolutions in the stepper motor. So the answer is B. Question. The robot uses a brush type DC servo motor as its drive. The current flowing through the armature is 20 amps and the motor torque constant is 2.25. The motor speed is 1500 RPM. What is the power developed by the robot drive? A 6.2 kW, B 8 kW, C 7 kW. So torque developed is equal to, because in brush type DC servo motor, T is proportional to I, or T is equal to K into I, where K is the torque constant. So torque developed is equal to torque constant into the current. So 2.25 into 20, that is equal to 45 Newton meter. So power, we know the very well known equation, power is equal to 2 pi nt by 60. So 2 pi into 1500 into 45, because RPM is given as 1500. So 2 pi, N is RPM, T is the torque developed. So 2 pi into 1500 into 45 divided by 60, that is equal to 768 watts or 7.068 kilowatts. So the nearer answer is 7 kilowatts. Okay. So the answer C is the option C is the answer. 27, question number 27. A stiff cardboard carton weighing 10 Newton is held in the gripper using friction against two opposing fingers. The coefficient of friction is 0.25. The orientation of the carton is such that the weight of the carton is directed parallel to the finger surfaces. The required gripper force is A 10 Newton, B 20 Newton, C 30 Newton. So the hint is, so the gripper force is equal to the weight divided by number of friction finger surfaces into coefficient of friction. Simply remember W by Nu. W is the weight, N is the number of finger surfaces, and coefficient of friction mu. So W, the weight, is given as 10 Newton, divided by number of friction surfaces. There are two finger surfaces. So 2 multiplied by the coefficient of friction, that is 0.25. So 10 by 0.5, that is equal to 20 Newton. Okay. So the answer is B, 20 Newton. So that is the answer for 27th question, answer B. Question 28. A 5 kg rectangular block is gripped in the middle and lifted vertically at a velocity 1 meter per second. If it accelerates to this velocity at 27.5 meter per second square and the coefficient of friction between the gripping pads and the block is 0.48, calculate the minimum force that would prevent slippage. A. 222 Newton, B. 150 Newton, C. 194 Newton. So the hint is, so we have to consider the balancing of forces. So the downward force weight of the body plus force due to acceleration, that is equal to 2 into friction force. Why I am using this 2 is because we are having it is gripped in the 2 finger surfaces. So I am using 2 into the friction force. So W plus MA, the force due to acceleration is, we know F is equal to MA. So MA is equal to 2 into friction force is mu into Fg. Okay, the gripping force mu into Fg. Fg is the gripping force. So Mg, W is mass into the acceleration due to gravity, Mg plus Ma is equal to 2 into mu Fg. Or I can take M outside. So M into A plus G or G plus A is equal to 2 into mu Fg. So from this, Fg is equal to M into G plus A divided by 2 mu. Substituting the values, the mass is 5 kg. We know G value 9.81. The acceleration given is 27.5 meter per second square divided by 2 into the friction factor, that is mu is 0.48. Okay, so that is a coefficient of friction 0.48. Then calculating this, the gripping force is equal to 194 Newton. That is the answer C, 194 Newton. So question number 29. A vacuum cup gripper is used to lift flat plate of stainless steel weighing 250 Newton. The gripper uses 2 suction cups and each suction cup has a diameter of 125 mm. The pressure required to lift the weight is roughly A. 10 kilopascal, B. 5 kilopascal, C. 20 kilopascal. So the pressure required, which is equal to the weight by area. Here we are using 2 suction cups. So we have to take twice the area, W by 2 into pi d squared by 4, that is equal to 250 by 2 into pi into, the diameter is 125 mm, I am converting it into meter, 0.125 squared by 4, that is equal to 10,185 Newton per meter square. Okay. So 1 Newton per meter square, we know that is equal to 1 Pascal. So 10,185 Newton per meter square is equal to 10.185 kilopascal, or roughly it is equal to 10 kilopascal.